Okay, so going back to this from Tuesday, real quick here. Those were our 4 strategies: taking something out, difference of 2 squares, trinomial, and grouping. So we did taking something out, we did trinomials, we did grouping. The only thing we didn't do is differences of 2 squares. So that's the first thing we're going to start off with tonight, is differences of 2 squares. Okay, so kind of like what I did before, I'm going to just kind of give you develop a little bit here. All right. So if we take something like this, say x plus 3, and we square it, what we want to do is write it twice, okay, and then FOIL that. So we're going here, 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 okay, and then combining. Okay, so that's 2 squares, all right? But if I take one like this, where this is a 3, and I FOIL this one, then we end up with this, because these into terms are canceling. All right? So this one is actually called a difference of 2 squares. Because this one is a square and this one is a square. All right. So what we're going to do is start off with this problem and work back to here. Okay, so we're unfoiling again, but this technique is called the difference of 2 squares. One thing that might be helpful is to someplace write down, we'll do this here. Oops, not that bad. So if this is the number n, then this would be the number n squared. So the numbers on the right are all perfect squares. All right? And of course there's more, but I didn't go much further than that. So when we're doing problems that are differences of 2 squares, the numbers on the right are the ones that you want to look for. So if you're really good at knowing those things, I guess you don't need this little chart. But if you need to know what squares are, there's the first 9 of them. Okay. Of course, here I can add a couple more. I don't know how many you're gonna actually see. So with, like those other ones, we were taking something out, trinomials, grouping was 4. The difference of 2 squares is usually always 2 terms. Well, here I'm just going to say that's factor. So a difference of 2 squares might look like this. All right, so we have x squared minus 36, because they're both perfect squares, 36 right here. Okay? Alright, so then all we have to do is drop parentheses down, put an x here and an x here. The square root of 36 is 6. 6 is going to go here, 6 is going to go here, and then one of them would be a plus and the other one would be a minus. Alright? So there's two reasons actually that it's called a difference of two squares. Difference meaning there's a minus here. Alright? And also we can think of as a difference in that those two signs have to be different. All right. So that's what a difference of two squares looks like. So let's try another one here. This time we have x squared minus 64. Again, 64 perfect square. All we got to do is drop this down. X square root of 64 is 8. Okay? And that's the difference of two squares. Now you will also see some that look like this. Okay, so in this case we have 4x squared minus 25. This is also a difference of two squares because not only is the 25 a perfect square, but the 4 is also. So if we look on this chart, we see we have 4 and 25. Okay, so then this is a difference of two squares. So we drop down the parentheses. Okay. 2x is going to go here. 2x is going to go here. And what's the square root of 25? What does this chart say? 5. So we put a 5 here. We put a 5 here. Plus, minus. There it is. Okay. That's a difference of two squares. So anything in that type of format, okay, is a difference of two squares. So even something like this is a difference of two squares. Again, because the 100 is a perfect square and x to the fourth is also a perfect square. What would the power be on the x? 2. Yep, good. Okay? So anything in that format, difference of two squares. Here's where a lot of people will make a mistake. I see this all the time in all these classes. X squared plus 81. So then people will come down here and they'll say this is x plus 9 and x plus 9. The problem is when you FOIL this, that's not what you get. So this one is not the same as this one. All right? So you have to really be careful that a difference of two squares means that has to be a difference. Okay? This one here, that cannot be factored. There's no way to factor that. Okay? So be careful of those. That's where a lot of the big mistakes come in with differences of two squares, is that you're kind of cruising along, and then they throw a plus at you, and then they can't. You think, oh, I can do this one as x plus 9, x plus 9. No, it's not the same thing. Any questions on the differences of two squares? Okay, I'm going to go back up to the very first thing we did. This also has a name, all right? Now, I don't really care that you do it this way, all right? But the book talks about this and says this is a trinomial square. Which comes from this, x plus 3 quantity squared. All right, you can't really recognize it so much, but if you take x plus 3 times x plus 3, you get this thing. And it's a trinomial square. And I guess you could say, well, the square root of 3 doubled gives me 6. And that's kind of how you recognize it. However, if it was me, I would just factor that as a trinomial and forget all about trinomial squares. Because you can take any trinomial square, factor it as a trinomial, and get the problem right. And you don't need to know that those are trinomial squares. All right? You just don't. You can just go ahead and factor them. There isn't a trinomial square that you just can't factor normally. All right? So for example, here, if we take something like this, let's go with x squared minus 12x, okay, plus 36. All right, this is just a regular trinomial that you probably did some of these already in part of your assignment. So we're going to take factors of 36. They got to add up to 12, so that means it's got to be these. I drop down parentheses. I know I got to have two negatives because two negatives give me that positive. Two negatives add up to that negative 12. There's your trinomial square. You don't have to factor it any differently than any of the other trinomials. All right? So don't get caught up in the terminology of it. On the test that we're going to take, I'm not going to tell you which way to factor it. I'm just going to say factor them. All right? So then you just got to factor them.
So that is the answer to that problem right there. X minus 6.
Mm-hmm. Yeah, I would just factor them like trinomials and not worry about the trinomial square part. But you'll see that in your textbook if you look it up. If you look at it. The other thing that's in this section 6.4, okay, is the sum and difference of two cubes. Okay. Now, you're not going to be tested on this, but I would say that if you're going to take Math 95, it shows up in there, and it shows up numerous times. Okay. It's just the sum and difference of two cubes is something you don't spend a lot of time on mathematically except here. So, if you want, what you want to do is, let's see, where is it at? It's on page 447, and it says factoring the sum of difference of two cubes, and it gives you a formula for them. Okay? So I'm going to write it out for you, but it's also in your book on page 447. But I will write it out for you here. And again, this isn't something I'm going to test or quiz you on. Okay, so those are the formulas for it. I'll hang on here for a second. So what they're going to look like, these types of problems, would be something like this. Okay. Now, here, you need to know your cubes. All right. So we did squares. So cubes look like this. Come on. So this would be like n. This would be like n cubed. So since 8 is a perfect cube, then we could use this formula up here. Alright, so we'll go ahead and do that. Here's how it works. First of all, a cubed is just a, so x cubed is just x. So I put that there. B cubed, cube root of b I should say, cube root of b cubed is b, and the cube root of 8 is 2, so that goes there. Then you're going to take whatever this is here and square it. So it'd be x squared minus multiply those two.